Hey everyone, welcome back, and in today's video we're going to do one on C++ templates. Today we'll explore what templates are, why they're essential in modern C++ programming, and how to use them effectively. By the end we'll go through a detailed hands-on coding example to solidify the concepts. So what are templates? Templates in C++ allow you to write generic and reusable code. Instead of defining a function or a class for each data type, you can define it once using a template, and it will work with the type you specify. Templates act as a blueprint. At compile time, the compiler generates the necessary code for the types you use, ensuring efficiency and type safety. In this code, t is a placeholder for any data type. When you call add with two integers, t becomes int, and if you call it with a floating point numbers, t becomes float. So why use templates? Starting off, we have code reusability. Instead of duplicating code for different data types, templates allow you to define a single function or a class that works universally. 2. Type safety. The compiler ensures that the types you use with the templates match. This helps catch errors early. 3 is the ease of maintenance. If you need to make changes, you only update the template code and it applies to all types. 4 for flexibility. Templates work for both functions and classes, making them versatile for solving many programming challenges. Templates for functions. Let's take a closer look at a function templates. Here's a basic example. This function can multiply two values of any type, whether they're integers, floating numbers, or even custom types, as long as the star operator is defined for those types. Templates for classes. Templates also work with classes. Here's an example. In this case, box represents a class that can store a value of any type t. When you create box int or box std string, the compiler generates a specific version of that class for those types. By using templates, you avoid duplicating logic and ensuring your code is flexible and efficient. Try modifying the code to experiment with other types like float or even custom classes. I'm going to cut the video so we can cut to the coding example. Hey everyone, welcome back. We're going to get started with our template example. We're going to be going over 8 different steps, so let's jump right into step 1. In step 1, we're going to start off by saying template, type name t. You can name t however you would like. It could be A, B, C. Another example is in linked list programs. When I incorporate templates into those, I call it node type. But for this example, we're just going to keep it at t, so you guys know that t stands for our data type. Now we're going to create our function called times of type t. In times, we're going to be sending in two values called a and b of type t. Now inside our function, what we're going to be doing is we're going to be doing our multiplication process. So all we're going to do is type return a times b. So now what we've done is our function template allows multiplication of values of any type t, so that could be integer, double, or floating point, and the type t must support the multiplication operator for this function to work, and return a times b will return the result of the multiplication. Moving into step 2, we're going to define our class template. We'll start off again by saying template type name t. It's very important to include template type name t at the top, so please don't forget that when you're defining templates in your class and functions. We'll create our class called pair. We'll start off by creating our private members. We'll create them of type t and we'll call them first and second. These are very important because they're going to be storing the values that we receive from the main function. Now we can write our public. And once we create our public, we're ready to move on to step 3, where we're going to be creating our constructor. Our constructor, we're going to call it pair because that's our class name. And just like we did in the times function, we'll send in our two values a and b of type t. But now we're going to want to initialize the members first and second to store the provided values that we get from a and b. So to do that, we'll write out first and we'll send in the value a. So a is now stored in first, and we'll do the same thing in second. But now we'll send in the value b. So now that our constructor is created, we can now move on to step 4, where we'll define the method to calculate the sum of the pair. So to do this, we'll create a function called sum. That's of type t again. And just like in the times function, we'll write out return first, but instead of multiplication, we're going to be using addition for this, and second. Now that we've created our class, we can now move on into step 5, which is in our main function, where we can now be sending in the values into our two functions. In step 5, what we'll do is we'll create a cout statement, and because we're going to multiply two values, we'll type out multiplication of the values, we'll use 3 and 4. Now once we do that, we'll send in the values, so we'll call the times function and send in the values 3 and 4. And that completes step 5 with our integer example. In step 6, we're going to do the exact same thing but with floating point. So we'll create our cout statement again. We'll do multiplication of the values. We'll use 2.5 and 4.5. Once that's done, we once again will create our times function. There's a typo here, let's fix that. We'll create our times function. Now we'll send in 2.5 and 4.5. Now that wraps up our template function example. So now we'll move into step 7, which is going to go over our template with classes and integers. So this is going to be slightly different. We'll start off by creating a pair of int. In that int, we'll create a pair. We'll do the values 10 and 20 for our pair. Now we can create our cout statement for our pair. This time we'll do, because we're using addition, we'll do sum of pair. Then we'll call our sum function that's in our pair class. So we'll do int pair dot sum and close out that cout statement. Now in step 8, it's going to be very similar to step 7. Create our pair again. Because we're going to be using strings, we'll do std string. Then we'll list our string values. So what we'll do is we'll do string pair again, and then we'll do quotation marks since we're working with strings. Hello, comma, we'll do a space. We'll do a space so we can separate them, comma again, more quotations for world. Now we can create our cout statement again. In our cout statement, we'll do the same thing we did in step 7. We'll do sum of pair. And then once again, we will call our sum function that's in our pair class. So we'll do string pair this time, dot sum, close it off, and then end the cout statement. Now when we run this program, you can see our two template functions, which is our multiplication, pop up, and our sum of our pair, which is our class. You can see when we multiply 3 and 4, we get 12, which is our integer values. And then when we do our multiplication of our floating point numbers, we get 2.5 and 4.5, which comes out to 11.25. Now in our sum pair, this is our class where we use our templated class to call to our sum function, which is first plus second. And that's where you get 10 plus 20 is your 30. And then with using strings, once again, because of our flexibility of using different data types, we don't have to create multiple functions for our strings, our floating points, or our integers. So we just change the type name t to string, and that adds our hello world together to form our sentence. I hope this template example really helped you guys out and you learned a lot, and I hope that you guys tune in for more coding examples. Thanks for tuning in.